right, guys, welcome back, and we're going to be getting into our second sort of like chapter, which is solving quadratic equations, is the 2.1 app. And so for the think slash warm up, I just have what is 0 times anything. That's not a trick question. The answer is 0, right? 0 times 2 is 0. 0 times -2 is 0. 0 times 0 is 0. 0 times anything is 0, right? And we're going to use that very basic fact to do something very powerful today. So the zero product property is just that, right? If you have A times B and it equals 0, then either A is 0, B is 0, or they're both 0. And that's going to help us when we're talking about variables. So right here, if we have x times x minus 7 equals 0, this is the real important thing right here, equals 0, that's the really important part, then we know that the solutions to that are x equals 0 and x equals 7. Why? Well, if x is 0, then we have 0 times, it doesn't even matter what's in here, right? 0 times anything is 0, so that's going to be true. And then 7, we're going to have 7 times, well, and then 7 minus 7 in the parentheses is 0, which is 0, so that's true too. So that helps us solve really easily for those. And similarly, down here, if we had x plus 3 times x minus 15 equals 0, again, you need that equals 0, then x equals -3 and x equals 15. And that comes from if x is -3, then in here you're going to have -3 plus 3, which is 0. 0 times anything is 0. Likewise, if you had 15 in here, then it would be 15 minus 15. That is not a minus sign. Minus, like that. Then you'd have 15 minus 15, which is 0 times anything is 0. So that's how we get those. And so one important thing we need is that a quadratic equation in standard form. By the way, quadratic equation just means x squared. That's all quadratic is. It just means having an x squared in there. And being in standard form just means we have it equal to 0. That's the real important thing. Again, that it's equal to 0. So for example, this one up here, 3x squared minus 8x plus 15 is in standard form, and the one below it, 2x squared minus x minus 3 equals -3x plus 1 is not in standard form because we would need these to be over on the other side. All right, so there's going to be a little bit of review because we're going to need it, and it's can we factor these? And when we have two things, it's either a difference of squares or a greatest common factor. And it's not a difference of squares because I have x to the 5th and none of those are squares. So I bet it's a greatest common factor. The biggest number that comes out of 27 and 24 is 3. And then we have x to the 5th and x to the 4th. So the most that they share in common is x to the 4th. And I'm asking 3x to the 4th times what? Gets me 27x to the 5th. And then it's going to be 9x, right? 9 times 3 is 27. X to the 4th times x is x to the 5th. Then we're going to have minus, and then 8 times 3x to the 4th is going to be 24x to the 4th, because we already have all the x's. So that's factored. Now we have one of these simpler ones. We need to multiply to -30, and we need to add to -7. And we can automatically set up our parentheses and do x times x to get that x squared. And now let's just think about this. Well, we have 1 and 30. That's not going to get us there. We have 2 and 15. 3 and 10. It's a horrible 3. 3 and 10. 3 times 10 equals 30, and that looks like it can help us if we have a -10 and a +3. That'll add to -7 and multiply -30. So x minus 10 and x plus 3. This is just quick factoring review, which is why I'm going a little fast. These ones with a number in front, we have to multiply the first and last number, so 2 times 7 equals 14. So now we need numbers that multiply to 14 and add to -9. 7 and 2, there'll also be -7 and -2. And then from there, we create our box. And in the box, we do 2x squared. And then this is where we use our numbers off to the right, negative. We do 2x there. It doesn't matter the order. -7x there. It doesn't matter the order for the 2 in the bottom left and the top right. But that 2x squared has to be in the top left, and then our +7 has to be down there. And then I like to look horizontally at this row at what I can take out between 2x squared and 2x. And the answer to that is a 2 and an x. If that's 2x, that means this has to be x to get 2x squared. That means this has to be -7. That means this has to be -1 to get +7. And just a quick check, 2x times -1 is -2x, which gets us to the top. So that works. All right. And lastly, this one looks like a difference of squares. When we see 4 and 25, we should that should pop on our heads that those are squares. And so this is the same thing as 2 squared minus, and then remember our trick when a number is attached is we kind of have to use that number as well and include it in there. And then the order matters, and then this is our 2 minus 5x, 2 plus 5x. And that should be a pretty quick review over things. I know I went fast, but again, we already covered it. You guys seem pretty comfortable with it. And so now it's time to use that. So solve for all values of x by factoring. So with each of these problems, our number one thing is we have to get it in standard form first if it is not. So we need an equal 0, right? Because we want to use that zero product property we had at the beginning. And the only way to use that zero product property is if we have something equal to 0. But in this case, we don't. So to do that, I'm going to need to add 6x. And I'm also going to need to add the 2 over. So plus 6x plus 2. And so that x squared isn't touched, right? We're still going to have x squared. And then negative 13x plus 6x is going to be minus 7x. And then 4 plus 2 is going to be plus 6. And then we're going to have equals 0. Well, now we can factor, right? We need a multiple of 6 that adds to negative 7. This is one of the ones that you don't want to overthink, right? Negative 6 and negative 1 do the trick. And so what we're going to get is x minus 6, x minus 1 equals 0. And now what we do with this information is different, right? We've already factored before. This is different. We are solving the equation. And so what I like to do is I like to draw a little squiggly down the middle, and I like to set each of these sides equal to 0. So x minus 1 equals 0, and x minus 6 equals 0. And then I just solve for x. So if I add this 1 over, then I get x equals 1. And if I add this 6 over, then I get x equals 6. And so my two solutions are x equals 1 and x equals 6. And on delta math, it will want two solutions. And to get two solutions, you just need to, you can either hit a comma will give you like two little spaces and it'll put like squiggly brackets around it. And you put your two answers in there. Or there's a little plus sign on the right, kind of by where that calculator keyboard is at. And this makes sense, right? Because if x is 1, then looking at, I'm going to do a different color. If x is 1, then looking here, we're going to get 1 minus 1, which is 0, times whatever this is going to be 0 times anything is 0, right? And same thing, if x was 6, you get 6 minus 6 on the left, which is 0 times whatever this is going to be 0. So that's why those solutions work. So down here, Same thing again. This time we need to add this 3x over because we want to be in standard form. We need that 0, right? So we're going to get x squared minus 10x plus 3x is minus 7x. And then negative 3x plus 3x is going to be 0. Oh, this doesn't look like a trinomial. This is why we need to know and have an understanding of factoring, right? So that we can get this answer. So it doesn't look like a trinomial. Don't be confused when you have two terms. It's either a difference of squares or a greatest common factor. Not a difference of squares. 7 isn't a perfect square. So it's going to be a greatest common factor. And you'll be like, oh, well, there's an invisible 1 in front of the x squared. I can't pull anything out of 1 and 7. But don't forget, they both have an x, don't they? So if I take out an x, then I'll be left with x times x is x squared, and x times negative 7 is minus 7x, or equal to 0, which is important. And now where there's multiplication, I'll split it up, and I'll say x minus 7 equals 0, and x equals 0. Well, x equals 0 is already solved for us, so that's nice. And then we just add this 7 over to get x equals 7. And so those are our two solutions, right? X equals 0 and x equals 7. And that's because if we plug 0 in, 0 times anything is 0, and plug 7 in, we're going to get 7 minus 7, which is 0 times anything is 0, right? So, and you might get good at realizing that, if you have x minus 7, you might not have to do this squiggly line. You can be like, oh, if x is 7, that's going to be 0. And if you see that x there, you're like, oh, if x is 0, that's going to be 0. That's totally fine. Just be careful if you. I think we'll see an example of why you might have to be careful with that in the future. So same thing, we need to get it in standard form. So I'm going to add this x and subtract this 4 over in one swoop. And when I do that, add x, subtract 4. Then this 5x squared is just going to come down. And then 3x plus 1x is plus 4x. And then plus 3 minus 4 is minus 1. And then we're going to end up with 0 on that side. So, and now we have to do our thing, right? 5 times negative 1 is negative 5. So now we need to find two numbers that multiply to negative 5 and add to the middle term 4. Again, don't overthink this one. This is going to be 5 and negative 1. And then from there, we make a box, right? So we have to make our box. 5x squared is going to go in this top corner. We're going to put 5x here, negative 1x or just negative x there. And then in this last one, minus 1, because we're looking at this equation now that we're in standard form, right? So the most that can come out of 5x squared and 5x is a 5 and an x. And if that's 5x, I know that this has to be x to get the 5x squared. And so then I know that has to be a minus 1. And then I know that that has to be a 1. And so what we get is 5x minus 1 times x plus 1 equals 0. And so now I think, this is where it becomes a little more helpful to draw those lines, right? So now we're going to set 5x minus 1 equal to 0 and x plus 1 equal to 0. And you see, this is where it might get a little tricky. So we're going to add that 1 over. Then we're going to get 5x equals 1. And then divide both sides by 5. And we're going to get x equals 1/5. And here we just subtract the 1 over. X equals negative 1. So here we have two solutions in. We have x equals negative 1 and x equals positive 1/5. And delta math is going to want it as 1/5, not as a decimal. And so our last one here, this board's a little bit behind me. Our last one here, we're going to have x squared plus 2x equals negative 5x. Oh, we already did that one, didn't we? Yeah, this is not what I meant to do. I'm going to make one up on the spot. So we have, let's think about x squared. Let's do minus 2x plus 14 equals negative 2x minus 2. Let's do that. So again, we're not in standard position, so or standard form, so we're going to need to add 2x and 2 to get 0 on this side. And what we do to one side, we have to do to the other. And so we're going to get x squared minus 2x plus 2x actually go away. 14 plus 2, or let me change this. I just want that to be negative. Sorry, guys. So negative 6 or negative 14, and then I want to do plus 2. So we're actually going to add 2x and minus 2. So add 2x, those are still going to cancel. And now we are subtracting 2. Okay, so now we have x squared. Negative 14 minus 2 is minus 16. And 2x plus 2x and 2 minus 2 cancel out. And we're left with 0 on this side. So now again, 2 terms, and it's not a greatest common factor. We should recognize 16 as perfect squares. So x plus 4 and x minus 4. And so we do our little squiggly lines. X plus 4 equals 0, and x minus 4 equals 0. And we are going to end up getting x equals negative 4 once we subtract 4 over, and x equals 4. And so those are our two solutions. You could write x equals negative 4 and x equals 4. And another way to write that is you can just write x equals plus or minus 4. That's just a little extra thing there. So sorry about that last one. I must have accidentally slapped the same one on there and I meant a different one. But that's okay. You guys get the point. You just need to know how to factor, how we factored before, and you will be okay at solving this.